Hello and welcome to this NEP for geometric sequences. It actually forms part of a sequence itself with arithmetic sequences and series and geometric sequences and later series. So this is introducing a new type of sequence where we're going up by multiplying rather than by adding and subtracting. So a geometric sequence has a common ratio between each term. Now that common ratio is what we are multiplying by to get from term to term. So multiplying by r generates the next term of the sequence. un times r equals un plus 1. So what that means is if we take a term, we times it by the ratio, we get the next term. Now what that actually means, and this is really important, is that means that if we take a term and divide it by the previous term, that's going to get us r for any consecutive terms. So r could equal u2 over u1, or anything up to u50 over u49, as long as we are doing a term divided by the preceding term. Now we have another formula for this. You have to learn this one. This isn't given to you. The formula for the nth term, so the general term of a geometric sequence, is un, so we've got that same notation as an arithmetic, equals ar to the n minus 1. So the only thing that's different is we have an r, we have a ratio, rather than a difference. Now the blue box is really, really important today. It says a geometric sequence will converge, and what that means is each term gets smaller if r is less than 1. So if r is smaller than 1, each term is going to get smaller and smaller and smaller. And we'll actually see an example of that in the first example. So moving on, we want to write our examples down here. We are going to be doing these nice and neatly. Again, keep them with your notes, keep them nice and safe. So question number 1 is find the nth term of the following geometric sequence. And there is our sequence. Okay, so we're going to start with a box. Now, in here we have a, but then we have r, we still have n for the number of terms, and we still have un for the nth term. Now this is what we're trying to find, and because it's the nth term, we're actually going to have n in our formula, so n is going to go there. Now a is here already, 1024, but what we need to do is we need to find r. Now remember, up here, how we get r is u2 divided by u1. So r equals u2 divided by u1, and that equals a quarter. So that goes in here. So therefore, the nth term, using that formula here, un equals a r n minus 1. So the nth term formula is a times by r to the power of n minus 1. And that is my answer there. Now we're just going to talk a little bit about this converging. As you can see, every term is getting smaller and smaller and smaller. And that is because the r value, the ratio, is smaller than 1. So every time that is being reduced. Now what that means is when we eventually come to add it all up, then that is going to become so small that this will have a finite value for the series. Don't worry about that too much now. That's more for later on when we're looking at series. But this is really, really, really important to remember. Okay, question number 2. The 7th term of a geometric sequence is this, and the 3rd term is this. Now what we can do is we can write these as little mini formulas again. So the 7th term is ar to the n minus 1. So the 7th term, u7, equals ar to the 6, and it equals 1458. The 3rd term, u3, is ar squared, equals 18. So that's similar to the idea with arithmetic. Now what we can actually do here, we can divide these by each other, a bit like solving a simultaneous equation. So I'm going to divide this by AR squared, and I'm going to divide this by 18. So they're my two values from here. Now what's going to happen is the A's will cancel down. R to the 6 divided by R squared is R to the 4. So R to the 4 equals, and then I can simplify that fraction, which is 81. Now to find R, fourth root, so R equals 3. So solving simultaneously, using those mini formulas to arrive at my answer. Question 3. 3 consecutive terms of a geometric sequence are this, this, and this. Find the common ratio. Now, we had a similar type of question in arithmetic sequences where we had terms in terms of an unknown. But what we want to look at here is, rather than there being a common difference, there's a common ratio. So R equals U2 over U1, or it could equal U3 over U2. So U3 over U2 is the same as, because it has a common ratio, U2 over U1. And now what I have here is I have a complex but solvable quadratic just in terms of x. So what I'm going to do is I'm going to cross multiply because there's an equal sign. So I have a series of double brackets, and I can then expand. So minus 2x squared minus 18x plus 6x and then I can start to simplify again. So I'm gonna add 2x squared here. I'm going to add 12x, and I'm going to minus 54, which leaves me with 0. Like so. I can solve that on my calculator. 3x squared plus 6x minus 45. So x equals 3 or minus 5. And what I need to do is I need to consider what those two values of x are going to do. So I haven't actually found my answer. So R equals, R is this or this. So if I sub that in, if x equals 3, then R equals, so 2 lots of 3 minus 6. I'll write this down actually. Now that's going to equal 0 on the bottom, so that is not possible. If x equals minus 5, then R equals, put all of that in my calculator, equals 2, so R equals 2. And that is my final answer. I'm also just going to sub x into here, just to be sure. That's a nice way of checking. So minus 5 minus 3 over minus 5 minus 9 is also 2. So that is my answer. Okay, so now we want to think about a summary. So this was our first introduction to geometric sequences. Okay, so to find R, U2 divided by U1, and that is the same as U3 over U2, etc. And then we're just going to add here, you can also solve simultaneously, e.g. AR5 over AR cubed is going to give you r squared. So that is about finding r. And then the other thing that we're going to remember is if, and we have the modulus, because it doesn't matter if that is a negative value as well. If r is less than 1, the sequence will converge, and it will converge to a limit. And that will mean that the series, the sum, can be added up to a finite limit, but we'll come to that later on as well. So I think that's all we need for our summary. So we're going to put that in a little box there. The crucial thing is just finding r every time. So put that in a box, write that down, keep it nice and neat, keep it nice and clear, and then we're going to go on to the practice questions. Okay, here are the practice questions for arithmetic sequences. So ideally you want to do these somewhere separately from your notes. Keep your notes nice and separate, nice and neat and tidy, and then we're going to do these somewhere else. Okay, so question 1. The second term of a geometric sequence is this, and the fifth term is this. By first finding r cubed, find the values of a, r, and the nth term. Okay, so the second term, remember our mini formula, so that's a, r to the 2 minus 1 is this, and a, r to the 4 is this. So remember we said we can divide by a, r1, divide by minus 4/3. Now the a's cancel. I'm going to get r cubed by first finding r cubed, and then I need to put those fractions in my calculator. So that is minus 8 over 27, cube root, minus 2/3. Okay, now if a, r is minus 4/3, we know what r is now. So a equals 2. And then we can actually construct a box over here. So a equals 2, r is minus 2/3, and the nth term, n equals n. So un equals a, r, n minus 1. And that is your answer. Now just note, the r value is less than 1. Even though it's a negative, the modulus of that, the absolute value, is 2/3. So this sequence is going to converge, get smaller every time. Okay, B. Geometric sequence is this. Find the value of n for which un is first less than 9. Okay. So, box. A equals 500. R equals U2 over U1, or 3/5. The value of n, so n is what we're looking for, is less than 9. So un is 9. Now, using the nth term formula, un is 9, is a, r, n minus 1. And now I'm solving this. So 9 divided by 500 first. Leave that as a fraction. Now what we need here is we need to use logarithms. So log of 0.6 to the 9 over 500 is n minus 1. Now I'm going to evaluate that. It's going to be a fraction, which is fine. 9 over 500, or it's going to be a decimal in fact. So n minus 1 equals, so therefore n equals 8.86 ... So the first value of n for which it is less than 9, so n equals 9. And then I'm just going to check that by putting 9 in here. So 500 to the 0.6 to the 9 minus 1 gives me 8.39, which is less than 9, so that seems sensible. Okay, C, the first three terms of a geometric sequence are this, this, and this. By considering these, find R. Okay, so R equals U2 over U1 or U3 over U2. So x squared over 2x equals 2x over 8 minus x. And actually, before I cross multiply, I'm going to simplify the x's and that x there. And now I'm going to multiply because there's an equal sign. So 8 minus x, x equals 4x. So if I minus 8x, then we get x squared minus 4x equals 0. Okay, and now we want to check these. So x squared over 2x, if x equals 0, it's 0 over 0, which is not possible. So if x equals 4, x squared over 2x r equals 2. And as we said, I'm just going to sub it into this other one just to check. So that is my answer. Okay, so that's geometric sequences. The next NEP is geometric series, and as I said, it's all part of this little sequence of NEPs on sequences. There then comes two more on recurrence relations and sigma notation. So if you're interested in those, you can find them at www.stutchfield.com, and there's plenty more NEPs out there for you.